Hi, are you there?
Yes.
All right. So the last thing we did was examples of aromatic compounds, and now we're going to start off with naming of aromatic compounds, right? So naming is basically called nomenclature, and there are a few rules for naming, and you need to remember those. Aromatic compounds with more than one substituent on the ring can exist as positional isomers. Now, what are positional isomers? Positional isomers are isomers with the same substituents at different positions. Now, what do I mean when I'm saying substituents? For example, this is my benzene ring, right? And I have a chlorine attached here, and I have another chlorine attached here. So I can call this chlorine and this chlorine as substituents, right? Something additional that is attached to my benzene ring. So both of these are substituents. Now, if I want to make a positional isomer of the same compound, meaning the formula stays the same, I can shift these chlorine atoms anywhere around the ring and I get like a positional isomer. So I could shift these chlorine atoms. I could keep one here where it already is. I could shift the second one somewhere here. Another isomer that I can make is I can keep the first one here and I can keep the second one here, right? Now, what I will not do is I will not place a chlorine here. Why? Because this structure and this structure will then look the same, right? This is basically laterally inverted, right? It's been flipped, right?
Okay.
Which is why I will not place my chlorine atom here. I will also not place my chlorine atom
On the other
here,
side.
right? Why? Because if I flip both of these, it's going to give me the same compound, right?
Okay.
So the three positional isomers that I can get are these three, right? Now, how do we come to name these, right? What we firstly do is we start to number the points. So this is my first position, second position, third, fourth, fifth, and sixth, right? Now, where are my chlorine atoms? My chlorine atoms are on the first and the second positions, right?
Yeah.
So I will name this as 1, 2 dichlorobenzene. Why will I name it di?
There's two
Because
chlorine.
exactly, there's two chlorine atoms. If there were three chlorine atoms, I would have named it as trichlorobenzene, right?
Yes.
So it's 1, 2 dichlorobenzene. The same case is going to be applied here. There's 1, 2, 3, 4, 5, and 6, and we have chlorine on the first and the third position. So this will be named as
1 and 3 dichlorine.
perfect.
Chlorine.
And 3 dichlorobenzene. This one is 1, 2, 3, 4, 5, and 6. So there it's on 1 and 4. So this will be 1, 4 dichlorobenzene. Now we move on to the major part of naming substituted benzene. The name of the substituent is usually added in the front of the word benzene. So there are rules. There are some substituents that come before the word benzene, and there are some substituents that come after the word benzene. Now, the ones that come before are very usual and they usually occur. The after ones are just two, that's carboxylic acid and esters. And before are fluoro, bromo, chloro, iodo, nitro, and methyl. Now let's discuss what this actually means. When I say that chloro is the word that comes before benzene, an example of this could be these three. 1, 2 dichlorobenzene. So chloro comes before benzene in all of these examples, right? This means that if I have a chlorine atom, if I have a fluorine atom, if I have a bromine atom, iodine atom, a nitro group, or a methyl group for that matter, all of these substituent names are going to come before the word benzene when we're naming these, right? So there are a
Yes.
few examples that we'll be discussing. Let me just put my laptop on charge. Give me a minute. Okay. Now, this is my benzene ring and I have a nitro group attached to it. Now, we know that when I have a nitro group, it's going to come before the word benzene. So this will be named as nitrobenzene. Nitrobenzene. And here we see that nitro comes before the word benzene. Another example is I have a benzene ring and I have a methyl group attached to it. Now, methyl group also comes before the word benzene, right? So this will be methyl benzene, right?
Okay.
Another example could be this, for instance. Now, what's my substituent here? My substituent is an acid, right? Can you hear me?
Yeah.
Okay. So my substituent here is a carboxylic acid. And a carboxylic acid, as written in the notes, comes after the benzene ring, right? And whenever it comes after the benzene ring name changes to phenyl, okay? So this comes after, so that means that phenyl comes before and the acid comes later, right? It comes after benzene. So acid is ethanoic acid. It has two carbons, right? So it's going to be named as ethanoic
You
acid. So my structure's name will be phenyl ethanoic acid, right? Understand?
yeah.
So this is how we're going to name our compounds. Now, for instance, in all of these examples, we have just one substituent, right? There's one nitro, there's one methyl, there's one carboxylic acid. Now we'll discuss how do we name compounds when we have two substituents. If the two substituents are different, one of them becomes the root group in the following order. Now there is a list which goes according to precedence, right? So first there comes carboxylic acid, then there's the hydroxyl group, then there's the methyl group, then we have halogens. Halogens are chlorine, fluorine, bromine, iodine, etc. Then we have the nitro group. This is in decreasing order of precedence. Now let's look at an example. Now I have a benzene ring that has two substituents. This is my benzene ring. This has a carboxylic acid and it has a hydroxyl group, right? Now what we're going to do is we're first going to be seeing where both of these come in the order of precedence. So there's carboxylic acid, which is here, and then there's hydroxyl group, which comes later, right? So precedence is given to carboxylic acid first, and then had the hydroxyl group, right?
Yeah.
Now, the notes say that if the two substituents are different, which is our case, one of them becomes the root group meaning the name of the benzene ring, and the other one is named before. The name comes before. So how do we make it part of the root name? What do we need to make part of the root name here? The carboxylic acid, right? Because it's given more precedence, right?
Yeah.
So when the carboxylic acid is to be made part of the root name, we call it benzoic acid. Right?
I
So
didn't get
you didn't get it?
no.
Okay. So this is your decreasing order of precedence. You can also call it a decreasing order of importance, right? So if you have your carboxylic acid group and you have a hydroxyl group in the same compound, which one is to be given more importance?
Carboxylic.
Carboxylic, right? Now, the one that is to be given more importance becomes part of your root name. For example, the name of this compound is 3-hydroxybenzoic acid. Now, why have I named it like this? Firstly, position number 1, 2, 3, 4, 5, and 6, right? So since carboxylic acid is to be given more importance, it becomes part of the root name, meaning the main part of the compound, right? 3-hydroxy is basically the added substituent to this,
Yeah.
right? So the main part of this compound is basically your carboxylic acid. If I were to name just this structure, I would name this as benzoic acid. ठीक है?
Yeah.
I have an added substituent here, which is an OH group, right? So this is something that has been added, right? So this added thing will come before benzoic acid. This is your root name, meaning the main part of the compound. And since I'm now adding an OH group, this will be on the third position. So I will be naming it as 3-hydroxybenzoic acid. Get it?
Yes.
All right, let's look at another example. In this one, I have a benzene ring again, and I have an OH group and a chlorine atom. Now let's go up and check the order of precedence. What do we have in here? We have an OH group and a chlorine atom, right? A chlorine is considered as a halogen, right?
Mm-hmm. So the OH is going to become the
Right.
part of
So the OH is going to be part of the root name, and this will be the substituent. Now there's two rules that you need to remember. That if your carboxylic acid is part of the root name, it's going to be named as benzoic acid. If your OH group is part of the group name, of the root name, it's going to be named as a phenol. And if an NH2 is part of the root name, it's going to be named as an amine. This is basically an amine, so this will give you phenylamine. Now, this looks like a lot, but when we're going to be starting with reactions and everything, this will basically literally become part of chemistry language. You won't need to remember the rules, right?
Yeah.
Now here, we have an OH group and a chlorine group, and we just discussed that OH will be part of the root name in this case, right? Now, what do we call an OH in a root name? It's called a phenol, right?
Yeah.
So how will we name it? 1, 2, 3. Now the root name is phenol, and I have a substituent attached to it, and this substituent is on the third position, right? So this will be 3. Complete the name.
3-chlorophenol, right?
Perfect. Yes, 3-chlorophenol. Now, what if I have a chlorine atom here, a nitro group here, and another nitro group here? So I have chlorine, which is a halogen, and I have a nitro group, right?
Yeah.
What will be my root name?
The halogen.
The halogen, right? So the halogen here will be my root name, and my nitro group is my substituent. Now my chlorine is my root name, so I'm going to start numbering my compound from chlorine. 1, 2, 3, 4, 5, and 6. And since chlorine is the root name, I'm going to name my compound. If my compound was just this, I would have named it as chlorobenzene, right?
Yeah.
However, now we have added substituents to it. We have added a nitro group and we have added another nitro group, right?
Yeah.
So I need to add these substituents to this name, right? Now my nitro group is on the second position and the fourth position, right?
Okay.
So I'll be naming what?
It's gonna be is it gonna be 2,4-amine chlorobenzene?
Look, amine is NH2 and nitro group is NO2. Don't mix the two of these, okay?
Okay.
Right now we're talking about the nitro group. So we'll be naming this as 2, 4, since the nitro groups are on the second and fourth position. 2, 4, nitro, what? Give the name? Chlorobenzene.
Yeah.
So what do we do when we need to name all of these? we first see the order of precedence. Then we decide which one needs to be the root name, which one needs to be the substituent. Then we number our compound. And then we name it. Right?
Yeah. Okay.
Now, one last example. So in this one, I have an OH group and chlorine atoms, right? Now let's check the order of precedence. There's chlorine and there's an OH, right? So my OH will be the root name since it comes higher in the order of precedence. And my chlorine here will be the substituent, right?
Yeah.
And OH as the root name is called
Phenol.
phenol, right? So my root name, meaning that if I just had this compound, I would have named it as
Phenol.
phenol. Now I have added substituents to it, which are chlorine atoms on the second, fourth, and sixth position, right? So my root name is phenol, and I know that something needs to come at the back of it, right? And what needs to come at the back of it are the names of the substituent. So how will I be naming this?
2,4,6 chlorophenol.
Trichloro, right? Because we have three chlorines.
Yeah. Okay.
Trichlorophenol. Now there are a few notes. Benzene becomes a substituent in itself when it is attached to the following. Let me know when you're done.
I'm done. I'm done.
So in the cases that we've already discussed, we are adding substituents to benzene, right? We're adding smaller compounds to a larger ring, right? In another case, in these four cases, these are exceptions. where you will have benzene as a substituent, right? Now, examples of these could be an amine. For example, you have an amine and you basically have a benzene attached to it. Now, in this case, what we're saying is in these four conditions. Now, right now we're discussing the second condition where you have a benzene ring attached to your amine. So here your benzene ring is your substituent. However, in the previous examples, your benzene ring was the major compound and your substituents were OH and chlorine, right? By substituents, I mean smaller compounds, right?
Yeah.
Another case is a two or more carbon acid. This could be, for example, I have an acid. So a two or more carbon acid can be any acid after ethanoic acid. Ethanoic acid, propanoic acid, butanoic acid, and so on, right? So there's methanoic acid, there's ethanoic, propanoic, butanoic, and so on. So methanoic acid has one carbon, this has two carbons, this has three carbons, and this has four carbons. Right now, what are we discussing? A two or more carbon acid. So two or more carbon acid, acids after ethanoic acid. So if I have ethanoic acid, CH2COOH, and I have a benzene ring attached to it as a substituent, right?
Yeah.
So here benzene is my substituent, and benzene is called phenyl when it is the substituent, right? And these are the cases when it is a substituent. So here we're going to be naming benzene as phenyl. So the name here is going to be phenylamine, right?
Yeah.
Here it's going to be phenyl ethanoic acid. So what's your root name? Ethanoic acid. And the substituent here is phenyl, which is your benzene ring, right? Get it?
Yes.
In this case, your root name is amine and your substituent is benzene, which is again phenyl. Now, another example is alkenes. So in alkenes, what we can have is, what if we have this alkene and I have a benzene ring attached to my alkene? So this benzene ring here is my substituent, and a substituted benzene is called phenyl. So my root name will be my alkene, which is here ethene, right? So my root name is ethene, and I will add my substituent, which is phenyl, right?
Yeah.
But this is only when we have these four conditions: a carbon chain with two or more carbons attached to the ring, an amine, which is NH2, a two or more carbon acid, meaning all acids after ethanoic acid, or when we have alkenes, right? So we've discussed all of these examples. Now, what if I have this attached to my benzene, CH2CH3? Does this condition satisfy any of the four conditions here? I have this attached to my benzene ring.
Yeah.
Yes,
No.
right?
Oh yeah. Look at the
It
alkene.
does, right? Which one
Yeah.
does it satisfy? It satisfies the first one, a carbon chain with two or more carbons attached to the ring. So there are 2 carbons, meaning in this case, this ring is your substituent, meaning this will be your root name, right?
Yeah.
So this is ethane. And this, since this is being considered as a substituent, this will be named as phenyl, right? So your final name will be
Phenyl ethane.
perfect, phenyl ethane. Example number 2. This is my benzene ring. I have a methyl group. Does this satisfy any of the conditions here?
No.
No, right? So here, your substituent will be
The
the methyl group, and the root name will be
benzene.
your benzene ring, right? So the root name is benzene, and your substituent is methyl. So this will be methylbenzene, right?
Yes.
Example number 3. Okay. Does this satisfy any of the conditions here? This has 3 carbons.
Yeah.
It does, right? So in this
Yes.
case, benzene is your substituent, and this compound is your root name, right?
Yes.
Now, since your benzene ring is a substituent, so a benzene ring as a substituent is named as
Phenyl.
phenyl, right? And your root name here is, how will you name this compound?
Propen.
Propane, right? So this
Yes.
is propane, which is your root name. So your name will go like something propane, right? And that
Yes.
something is
Phenyl propane.
phenyl propane. Okay, we're done with the naming. Now we need to do uses of benzene. Manufacture of insecticides. Example DDT. I'm making the structures, but they're not part of the exam. Okay, you just need to learn the major uses. Like example, manufacture of insecticides, right? These structures are not to be learned. The second use is antiseptics. For example, Dettol anti-CP. How will I name this compound?
Oh, it will be
Look, first we're going to see if benzene here will be a substituent or it's going to be a root name, right?
yeah.
So will it be a substituent or not? Does it satisfy any of the four conditions above?
No.
No, right? Because it has a methyl group, which is one carbon, another methyl group, one carbon, and chlorine and the hydroxyl group. So in this case, we're going to be looking at the order of precedence, which is this. Now, what were the compounds? What were the substituents that that compound had? That compound had a hydroxyl group. It had
Two methyl groups
two
and
methyl groups exactly, and one chlorine, right?
yes.
So what's the order of precedence? There's a hydroxyl group, there's methyl, and there's chlorine, right? So the root name will be what?
OH.
OH. This will be your root name. And the rest of the two will be your
Substitutes.
perfect substituents. And an OH as the root name is named as
Phenol.
phenol. So let's go back and name it. The root name will be phenol, right? And let's number it 5 and 6. Your methyl group is on the 3rd and the 5th positions, and your chlorine is on the 4th position, right?
Yeah.
Now, how do you know if you need to mention chlorine first or you need to mention methyl first? I know that I have 3, 4, sorry, 3, 5 methyl, and 4 pay I have chloro, right? Actually, this will be 3, 5 dimethyl because we have two methyl groups, right? Now, how do I know if I need to place my methyl first or my chloro first when I'm naming it? This is done through an alphabetical order. So there's a C and there's a D, right? Which one comes first?
The C. So we're
The
gonna
C,
say
right? There's going to be 4 chloro, 3, 5 di